Good morning. I am Dr. Mohammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today I want to discuss about socket address structure, IPv4 socket address structure, byte order functions. Introduction. Before going to the socket address structure, we have to discuss about introduction to socket. A socket is one endpoint of two-way communication link between two programs running on a same network. A socket is bound to a port number so that the TCP bytes can be identify the application that the data is destined to be sent to the client and server. An endpoint is a combination of IP address and the port number. The socket generally we can define the combination of the IP address and port address. With these, the combination of IP address and port number, effective communication can be established from client to server and server to client. Here, the sockets are used as a communication device or interaction between the client and the server, which receives the information from the client and send the information to server. After establishing the communication between client and server, disconnects it after receiving the data. Generally, the socket address structure, the socket use the socket address structure to pass or receive the messages. That means here, with the help of the socket address, the structure, we can send and receiving the information from client to server and server to the client. Several types of the socket, the communication, which will be depending on the address families. That is, for example, TCP/IP, Transmission Control Protocol and Internet the Protocol. SOC ADD it is a family. It is a socket the family. So which is used, these are the socket family, SOC ADD or underscore in, SOC address in. These are the family, it can be used in TCP/IP the communication. The socket address is a combination of the IP address and port number. With help of this IP address and port number of the client and the server, now we can establish the communication. We can transfer the data. In the TCP/IP layer, a socket is bound as a part of the number, which can be identified whether the data is to be sent to an application or not. That means here, this is the transport layer. Generally, you can use transport, these TCP/IP in a transport layer. So the data can be released at a application layer. From one client, now we can release the data from application layer. Here, the number of layers, OSI reference model, now you can see the number of layers, application, physical layer, data link layer. So it is a physical layer and so data link layer and network layer, transport layer, session layer, presentation layer. Finally, last layer is a application layer. So it is a client 1 and this one is a client 2, other 2 are server. Now the data can be released at application layer and transmitted with the help of this TCP/IP the protocols. So that can be sent to the another server or another the client to save the application the layer. So like this, now we can transmit the data from one application layer to the same another the application layer. So next, IPv4 socket address structure. IPv4 socket address structure. So an IPv4 socket address structure, commonly called an internet socket address structure, is named sock addr underscore in and defined by including the net inet dot h header file or in dot ho header file. IPv4 Internet Protocol version 4, so which uses the sock addr underscore in the family for transmitting the data from client to the server. Socket address structure, that is SAS. This socket address structure is established between the application and the kernel. Kernel is nothing but the core, the component of the operating system and the server. An address, the conversion function, translate between the text representation of an address and binary values. That makes a SAS, that is a socket address structure. IPv4 uses inet address and inet N2A families, but inet P2N and inet N2P handles the IPv4 and IPv6. Here is the internet the address. IPv4 using the internet address and inet N2A internet addressing. Internet addressing now, which is at converting to internet addressing to the string form. But here internet P2N, which is the converting this internet address. That means here to the string and string to internet address. inet P2N is reverse to the inet N2P. Here now it is converting from internet address, that is a port address, to the string, and here is now we are converting string to the port address, which can be handled by using the IPv4 and IPv6. IPv4 and IPv6 Internet the Protocol version 4 and Internet the Protocol version 6. These are the functions are the protocol dependent. However, these are the functions starting with the socket or protocol independent. Without the socket, if these the functions are starting or if these functions are communicating, so these are the protocol dependent. Once the socket is established at client side and server side, now we can say it as these two are the protocol independents. Most socket functions which requires a pointer to socket address. Why? Because the pointer refers the address of the client or address of the server. So the pointer to a socket address structure as an argument, used as an argument. IPv4 in socket address, IPv4 socket address, it is defined as hash include net, in net, internet or in dot h. Here the structure is IPv4 socket address structure. The code now can write it as the struct int addr underscore row in addr underscore t a underscore addr. So this internet address, so which is 32-bit IPv4 address. Now, so it is a network byte ordering. Struct this address, struct sock address underscore in. It is uint 8, unsigned integer 8 bytes. SIN length, that is a socket internet. SIN means socket internet the length. the length of the structure, that is 16-bit here. SA underscore family underscore T, it is a SIN family, that is a socket internet the family, that means here AF family, address family internet, we can say it as in underscore port underscore, it is SIN the port, it is a 16-bit TCP and UDP struck in address SIN address, that is a 32-bit IPv4 address, and char SIN 0 char SIN underscore 0, it is network byte ordering. IPv4 in socket addressing, various data types that are commonly used are listed below. So these data types here in a IPv4, generally IPv4 and IPv6, the communication, the socket, by using the socket address communication, now generally we can use these data type. So that is int 8, that means signed 8-bit integer. Now whenever we are using this the data type, now we have to use the header file as sys.h or type.h. Unit UIINT 8, that means unsigned 8-bit integer. Now whenever using these the data type, we can use the header file as sys.h or type.h. INT 16, that is signed 16-bit integer. Now for that, now we can use the sys or type.h header file. These, and while using these the data types, now we can utilize these header files. INT 32 UINT, that unsigned 32-bit the integer. SA underscore the family, that means here address the family of socket address the structure. Now we are using the socket dot header file. And next we'll see socket length underscore T, that is length of the socket address normally, that is UINT 32. For that, now we can use the socket.ho header files. In internet address, in underscore ADDR underscore T, internet address type, family type here, IPv4 address normally unit UINT 32 underscore other T. That now, for that, now we can use the net int.h or in.h as the header file. And in underscore address T and in underscore port underscore T. For this one, now we can use the TCP or UDP port normally UINT 16. That means here we can use the net int.h header file or in.header file. Length of these header files, now whenever you are using all these other data types, the length field is never used and set. So it is used within the kernel. That means the kernel means the core of the operating system or the server. Before routine that the deal with the socket address the structure from various the protocol families. See 4 socket the functions: bind function, connect function, send to function, send message. Now these are the function pass the socket address structures from application to the operating system or server, that is a core operating system or server. That means here all invoke the socket arguments in Berkeley derived implementations. These are the function copies socket address structures and explicitly set the SIN underscore LEN member to the size of the structure that was passed. Then the other socket functions that can pass the socket address to the application from kernel, that means the server, application to the server, which are accept the function receive from the server, receive message from the server or client. Get peer name. Get peer name means it may be the client. Peer names are client names. Now we can say it as a peer name. And that means a domain name also. And get a socket name. Here the socket name, which is by using this the function, we are getting the socket name. All set the SIM socket internet length member before returning to the process. Internet port socket internet family, that is SIN underscore family, or internet IN underscore port, internet port, or SIN underscore address. SIN means socket internet address, are the only required for POX.1G. So that is a portable operating system interface for system 1. SIN underscore 0 is implemented to keep the structure length to 16 byte. So if you want to keep the address structure length to 16 byte, now we can utilize the SIN underscore 0 function. Socket address, generic socket address structure. Socket address structures are always passed by the reference. When passed an argument to any of the socket functions, now we can use int bind int socket fd struct sock address sock length. But the socket function that accepts this address structure as a pointer must deal with any of the supported protocols. These calls for the any other functions must cause the pointer to the protocol specific socket address. Here to be the pointer to a generic socket address structure. For example, here struct sock underscore in server SERV. Here this is a generic socket address structure. This is an example for generic socket address structure. Here one more example, now you can say bind sock fd, that is a file descriptor, socket file descriptor, now which is binding. Generally this is the bind function which is binding the address and the port number for effective communication from server to the client. Here bind function we are using sock fd, structure sock address is a pointer type, and so which is refers the address of the SERV. Here which is referring the address of the server, and binding server address and port number can be the bind size of the that SERV. Here the length size of means which specifies the length. If you omit the cost in a C language, the C compiler which generate a warning. Here if you omit the cast here, now which is generate the warning of the form incompatible pointer type. Different socket address structures are generally we can use in a communication. IPv4 at client side and server side. Both the sides now we can use the socket for establishing the effective communication. IPv4 generally we can use the 24 byte address. And IPv6, IP Internet Protocol version 6, generally we can use the 24 byte length. Unix variable length and data link variable length. So these different socket address the structures can be utilized in a communication from client to network, client to server, or server to client. The communication, these are the different types of the socket address the structures can be utilized. IPv6 socket address structure. Here the header file is now include net inet.h or in.h header file. The structure here, so this is the structure. The struct int underscore address unsigned integer 8-bit underscore t and this one V6, that means the underscore address 16 byte, that means here 128 bit IPv6 address network byte address now we are using here. Hash define SIN6 length, hash define SIN6 length struck socket address. Now here is UIN unsigned integer, that is SIN6, the length of the structure 24. Here is SA underscore the family and AF address the family here in port T, that is transport layer the protocol here. Unsigned integer is a 32 the bit, so that is a SIN6. Now priority and flow labels can be utilized here. Struck in internet 6, the 6 bytes underscore ADDR SIN6, that means internet the socket internet is a 6 byte the address underscore the address, that is network byte ordering. This is a IPv6 socket address structure. So that is now we can say it as a socket address underscore in 6 internet socket address, that is a 6 bytes we can use. IPv6 important the points in a IPv6 socket address the structure is SIN length, socket internet length constant must be defined if the system support the length member of a socket address structure. For IPv6 the family is, that is a address family INET 6. For IPv6 now you can use the AF underscore INET 6 family for communication. The member in these the structures are ordered so that if the socket ADD underscore in 6 byte structure is a 64 bit aligned, so is the 128 bit SIN socket internet address. The SIN socket internet address, the flow information member is divided into 3 fields. The low order 24 bytes, low order 24 bits are the flow label, and next 4 bits are the reserved. Here next 4 bits are the priority, next 4 bits are the reserved. So you can see the comparison of the 4 socket address structures that are encountered. Here the first sock address underscore, that is internet the socket address, that is IPv4 and IPv6 unsigned integer and data link. So the comparison here is in this one here, now it is unused fixed length 16 byte. This figure is 3.1 here, it is a fixed length, so that is a unused, and 32 bit of the IP address can be utilized in a IPv4 socket address. And this is a 16 bit the port number. The port number the length is 16 bit, so it is a address family member. Address AF INET the family member. IPv4 is a address family member. Here also IPv6 also all are the IPv6 and UINT and data link, all are the, so these are all the these AF INET the families. Now all are AF families, but here IPv6 now the port number is a 16 bit and flow label is a 32 bit, and IPv6 address is now 128 bit now you can use, and path name here up to 104 bit in unsigned integer. So that is in Unix now in Unix unsigned the integer here, the path name is unsigned integer up to 104 bytes the variable length. So it is a variable length socket address. So Unix it is a 104 byte unsigned the integer length. So it is also AF local family. AF underscore local the family. So these two are the AF underscore INET family, internet family. IPv4 and IPv6 are the AF underscore internet the family, INET family. Here it is a AF local family, Unix, local host the family. And it is AF link family, data link. It is a linking family. And here the socket, it is a socket address underscore the D1. And interface index. Now we can use interface index. Type and name length. Address length, set length. So interface the name and link layer address can be utilized here. Variable length. Now the length is a variable length. Here also it is a variable length. Unix and data link are the variable length. Depends upon the user the requirement here. The length can be, now we can changing the length. So this is the comparison of the 4 socket address structures. That is socket address structures are the IPv4, IPv6, Unix data link. So these are the comparison of the 4 socket address structures. And value result arguments. When a socket address structure is passed to any socket function, it is always passed by the reference. The length of the structure is also passed as an argument. The way in which the length is passed depends on which directions the structure is being passed. Here, generally, we can pass from the processor to the kernel, that is operating system, and from the operating system to the processor, that is kernel to the processor. So value, the result argument can be the process, from the process to kernel, kernel to process. First, from the process to kernel, in which bind, connect and send to functions pass a socket address structure from the processor to the kernel. Arguments to these other functions are the pointer to the socket address structure, the integer size of the structures. So that is a arguments. Since the kernel is passed both the pointer and the size of what the pointer points to it. Now it know exactly how much data to copy from the processor into the operating system, kernel operating system. Here in this the figure now we can see the length, values, integer type, socket address the structure. That means here now data can be copied, data to copy from the processor to the kernel. Here whatever the data is present in this process, that can be copied to the kernel. That is a process to kernel data transformation and kernel to process data transformation. Here accept, receive from, get sock name, get peer name functions. These are the functions which is pass a socket address structure from the kernel to the process. The arguments to these other functions are the pointer to the socket address structure and the pointer to an integer containing the size of the structure. Struct address, socket address is unsigned CLI client. So here is a Unix the domain. Socket length underscore T. So it is a specify the length of the socket and length, the size of client. That means which is assigned to the length. Length is a value. Get the peer name Unix FD and SA socket address is a pointer type and which refers the address of the client and address of the length. Length may have the changed. Depends upon the types of the applications. Types of applications are utilizing or type of the communication, type of the data you are passing between the client and the server. Depends upon that it will be changed. Value result arguments. Value result arguments, the size changes from an integer to be a pointer to an integer because the size is both a value when the function is called and result when the function is returned. As a value, it tells the kernel the size of the structure so that the kernel does not write the past, the end of the structure when filling it. As a result now, it tells the process how much of the information the kernel actually stored in a structure. For two other functions that passes the socket address structure, receive message and send message, the length filled in not a function argument but a structure member. These are value result arguments. Now here kernel to process. Now we are passing the information from kernel to process, that is operating system. Whatever the data stored in a operating system or server, so that can be in a core operating system or a server, that can be the process. The protocol address, with help of this the protocol address, now we are transferring the data to the socket address, the structure in a process at the process user or the process. Now here the length, int is a pointer type, length is a pointer type. Now we are values, and values can be from processor to kernel, the values can be transferred here. Based on these the values, now the kernel which is perform the task, and result will be transferred to the processor. The processors now which is execute that, so whatever the result now which is observed, and that can be sent to the users. End users are applications which allow to the users and the applications. Value result, the argument in the socket address structure, it is a fixed length. The value returned by the kernel will always be that the fixed size, that is 16 bytes for an IPv4. Socket address, that is sock addr underscore in, and 28 for an IPv6 sock addr underscore in 6. But the variable length socket, the address structure, that is Unix domain sock addr underscore un, the value returns can be less than the maximum size of the structure. Here, the most the common example for the value result argument is length of the returned socket address structure. We'll encounter here other value result argument in the text. That means here in the middle, three arguments for the select function, the length argument for the get sock option functions, the message name length, message the control length members of this message HDR structure when used with receiving the message, that is RECV messages. If C underscore length member of the if configuration structure, the first of two length argument for the synchronous client the functions, and byte order functions. Byte order functions. Byte order functions, here there are two ways to storing the 2 bytes in a memory. With the low order byte at the starting address known little endian byte order, or with high order byte at the starting address known as a big endian byte order. So it is a increasing memory address. Increasing memory address, address A plus 1. Here in address A, low order bytes, we can store low order bytes, and address A plus 1, we can store the higher order bytes. So it is a little and byte order. That means low order to the increasing low order to the high order. Now here, if it is increasing the memory address from high order to the low order, we can say it as a big endian byte order. So here in endian byte, big byte order, here big endian byte order, the address is increased. Memory address is increased from high order to the low order. Here is starting with address A and increasing to address A plus 1. Byte order, the term little endian or big endian, which indicate which ends of the multi-byte values. The little end or big end is stored at the starting address of the value. Different systems use different ordering For example, PowerPC of IBA, SPARC of Sun Solaris, Apple of HP, all use big endian, while i360, i386 PC of BSDI and i586 PC of Linux use the little endian. The byte order used by a given system is known as the host byte order. The network programming, as a network programming, one end to deal with the different byte order, that is in the sending receiving protocol stack, must agree on the order in which the byte of the multiple fields are transmitted. Internet protocol uses big endian byte ordering for these multiple other systems. Here, normally the address structure may be maintained in the host byte order system. Then it may be converted into the network byte order as per the end user requirements. However, this POSIX, this interface operating system, the portable operating system interface, which specifies that certain files in a socket address structure be maintained in the network byte order. Therefore, there are the functions that convert between these two byte orders. These are conversion. Here, conversion unsigned integer 16 byte host, that is unsigned integer host 16 bit the value. So by using these other functions now, we can converting. Therefore, the function that converts between these two byte orders, that is a lower order to the higher order to the lower order. So we can convert. After converting here, the values can be written in a network byte ordering from lower order to higher order or higher order to lower order. After converting, now return the values in a host byte ordering, network byte ordering, network byte and host byte ordering. Appropriate functions are called to convert a given value between the host and a network byte order. On those systems, they have the same byte order as the internet protocol. These four functions are usually defined as a null macros.
Like, share and subscribe. Hit the bell icon for more updates.